Hello everyone, this is video 7.1. We're going to be defining ratios and proportions. So chapter 7 is on ratios and proportions. So this first section will just sort of be laying the foundation for the rest of the chapter. So let's get started. So if we're going to be discussing ratios and proportions, it makes sense that we define what ratios and proportions are. So a ratio is where we're going to be describing quantities that are mixed, combined, or related. That's the book's definition. Um, I think of a ratio as a comparison between two things, between two numbers, and those numbers typically are going to represent different things. And so we'll talk about how this acts in relation to a fraction here on the next slide. Um, but um, they're two separate ideas. They're two separate things, and they can be combined together. But for me, the way I think about a ratio, they could also be taken apart. So if I had like 1 cup of sugar and I scooped it out of 3 cups of sugar, and I put that back in, it's kind of hard to see. It's all one big thing again. It's all one big quantity. So typically for me, when I think of ratios, I think of things that are very separate and very distinct. A proportion is going to be a relationship between ratios. That's the book's definition. And that relationship typically is equality. So you have, for example, we have, say, 1/2 equals 2/4, or if we're going to use the language of ratios, 1:2 is 2:4. Now, this 1:2 is a ratio because it shows this comparison between two numbers. The 1:2. Now, this whole thing taken together is a proportion. So once we put those things in equality to each other, then they become a proportion. We'll see at the end of the semester the same thing is true in algebra. That if I have 2x plus 1 equals 5, this thing over here, the 2x plus 1, it has a specific name, and then this whole thing has a specific name. So this is not an uncommon thing to happen in mathematics where the individual parts have a name, but then once we put them equal to each other, they have a different name. So ratios can be part to part or part to whole. And this is probably the biggest distinction between ratios and fractions, because fractions are always this. Fractions are always in a part to whole relationship. And we've talked enough about fractions already this semester that you should sort of recognize this idea that the whole is broken into a certain number of pieces, and then that number of pieces to the whole gives us the denominator of the fraction, and the number of pieces that we take, that's the numerator of the fraction. So it's the same idea as this. So this part of a ratio we can also think of as a fraction. Where this becomes different is this. So this is a form of a ratio, this part-to-part form of a ratio that is very distinct from a fraction. Very, very distinct from a fraction. So try to be really careful that you don't talk about a ratio as just a fraction, or it's just a special form of a fraction. There is some overlap to them. I mean, there are some commonalities. That part to whole relationship can be thought of in a fractional way. And typically ratios are written kind of one of two ways. You see either they're written like this as a fraction, or you see them written like this with a little colon and show that relationship between. And I think a lot of times teachers will use this colon form to help reinforce that this is not just a fraction, that this is something different. But depending on what the ratio is, writing it like this allows it to have that flexibility between it being a ratio and being a fraction. So let's look at an example. I've got cans of soup and chili. So I've got cans of soup and chili. And let's just suppose that I have 7 cans of soup and chili, and 3 of those are chili. All right. Now, it's sort of implied in these problems. that there's not a third thing, that of those 7 cans, there's not like a can of tuna that's sort of in there throwing things off. And it's also sort of understood in these problems that there's not a soup that's also a chili. Sounds kind of weird, but also, so it's sort of understood that these two groups are disjoint, is the mathematical term would be. So we know that this sort of partitions that I've got 3 cans of chili. And so from this, I can tell the implication then is that I have 4 cans of soup. So I can write a bunch of ratios based on this relationship. I could write that my ratio of chili to soup is 3 to 4. I could also write that my relationship of soup to chili is 4 to 3. And we don't talk about this as an improper ratio like we would as an improper fraction. Because an improper fraction, that improper fraction lets us know that I have more than a whole of something. But in this case, we're comparing the soup to the chili. The chili is not the whole, the soup's not the whole. So this 4 to 3 would mean something very specific in a fraction, but it doesn't really have that meaning as a ratio. I could also write chili to all the canned goods that I have, and so this would be 3 to 7. And this would be most like this fraction 3/7, where 7 would be my goods and then the 3. But where this idea also sort of breaks down is that 7 has to be identical. And so these 3 cans and these 4 cans, they may not be the same size, they may not be the same shape. We know they don't contain the same goods. And so again, we can see they sort of act as a fraction, but they also at the same time really kind of don't on close inspection. I could also write this as cans to soup. And so then I've got 7 to 4. And so this is a part to whole relationship that's written whole to part. So I know I'm probably belaboring this point, but it's a really important point. So I don't think I know a lot of teachers. This line between what a fraction is and what a ratio is becomes very, very blurry. And if you just sort of dismissively say, well, one's just the same as the other, it's a huge misconception. And so we want to not reinforce that with students if we can keep from it. And well, we can keep from it. One way we can think about ratios is by making a table. So I'm going to make a mixture of 2 cups of peanuts with 1 cup of raisins. I'm going to make some trail mix. So I've got my peanuts and my raisins. And so I can make a table that's got peanuts and raisins. And so I've got 2 cups to 1 cup is one possibility. Well, what else could I make in this same ratio? If 3 cups of this is maybe too much, then I could do this as 1 cup with a half of a cup. And that keeps in this same ratio. We'll look a little bit more about solving proportions in the next section, but we can very intuitively see that to go from here, I've divided by 2, or to go back, I've multiplied by 2. So we can see this relationship. You take half of each, or if I'm going from right to left, take twice as much. So I can write this out. If this, I could also go 4 cups to 2 cups. I can show all of these ratios using this table. Now, I recognize that these are equal to each other, so one cup, let me fix that one. So 1 cup of peanuts to half a cup of raisins is in the same ratio as 4 cups of peanuts and 2 cups of raisins. Now, they're equal in as much as they show the same ratio. Clearly, they're not the exact same thing because the left is a cup and a half and the right is 6 cups. And it's a different quantity. But this equality is about the equality of the ratios, that they stay in this same relationship. So that's how we think about the equality of ratios, which we call proportion. So for your checkpoint, we have a class of 20 students, 8 of which have dark hair. What is the ratio of students who do not have dark hair to those who do? Again, we're working on the assumption that this partitions the class as a student either has dark hair or does not have dark hair. A student who does not have hair for whatever circumstance is considered to not have dark hair, et cetera, et cetera, et cetera. So this is partition between the two. So there's not meant to be anything tricky about this question. There's not meant to be anything tricky about the nature of students having hair or anything like that. It's just there's not anything that's meant to be, like I said, tricky or confusing. So what is the ratio of those? Think about the types of ratios that you have. Is one a part to whole? Is one a part to part? How do the parts and the whole sort of work together? So, uh, as always, we'll leave this problem. If you have any questions, by all means, please let me know. Thank you.